Road to Olympiad.
Welcome to RTO. Consider the following problem. Let a and b be distinct positive integers. Show that square root of ab is less than a minus b over ln of a minus ln of b is less than a plus b over 2. Square root of ab is less than a plus b over 2 is obvious from AM-GM inequality. But how are we going to prove that the given fraction is between them? Today, we are going to present one method that is pretty straightforward but can be very useful in a lot of time. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, without loss of generality, we can assume that 0 is less than b is less than a. Notice that even if a is less than b, ln of a is smaller than ln of b. So, both a minus b and ln of a minus ln of b are negative. So, the inequality to be proven is still the same in the case when a is greater than b. Here, in the setting of a is greater than b, we can let x is equal to a over b. And notice that this is a positive number. With this, we have a is equal to bx. Substituting a is equal to bx into the given inequality, we have b square root of x is less than bx minus b, the whole thing over ln of x, is less than bx plus b, the whole thing over 2. Dividing the b, finding the reciprocal, and multiplying by x minus 1, we have 2 times x minus 1, the whole thing over x plus 1, is less than ln of x, is less than x minus 1, the whole thing over square root of x. Here, it is to say that to show the given inequality to be true, it is equivalent to show only the inequality we mentioned just now for x is greater than 1. Now, consider fx is equal to ln of x minus 2 times x minus 1 over x plus 1. Then, the derivative f prime x is equal to 1 over x minus 2 times x plus 1 minus 2 times x minus 1, the whole thing over x plus 1 squared, where the second term can be simplified into 4 over x plus 1 squared, and the entire derivative into x minus 1 squared over x times x plus 1 squared. Since x is positive, it is clear that the result here must be positive as well, which implies that f is an increasing function. It is easy to compute that f1 is equal to 0, and thus, combining with the fact that f is an increasing function, we have f of x must be positive for all x is greater than 1. So, we have ln of x minus 2 times x minus 1 over x plus 1 is greater than 0 for all x is greater than 1, which gives us ln of x is greater than 2 times x minus 1 over x plus 1, which is the first part of our result. Similarly, we can consider g of x is equal to ln of x minus 1 over square root of x. Then the derivative g prime x is equal to 1 over x minus square root of x minus 1 over 2 square root of x times x minus 1, the whole thing over x, where again, the second term can be simplified into x plus 1 over 2 square root of x cubed, and the entire derivative into negative square root of x plus 1 squared over 2 square root of x cubed. Again, since x is positive, it is clear that the result here must be negative, which implies that g is a decreasing function for x is greater than 1. The same computation show that g of 1 is equal to 0, and thus for decreasing functions, we know that g of x must be negative for all x greater than 1. So we have ln of x minus 1 over square root of x is less than 0 for all x greater than 1, which implies ln of x is less than x minus 1 over square root of x, which proves the second part of the inequality and thus complete the proof for the entire inequalities. And this marks the end of our proof. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.